Yeah, good to go.
Okay, thanks, Joe. Hello, everybody. I'm not seeing some faces, but that's fine. It's very early in the morning here, and I hope everybody's doing fine considering the situation. Um, I wanted to just bring this up, and this is really the first time we're doing this, mainly because a lot of the problem with virtual learning has to do with passive learning, the problem of passive learning, and you know, basically you don't exactly know whether virtually kids are awake. Number one, number two, you know, they're probably eating while watching you on the screen. And if you're back in school, the same problem happens, which is they're still passive. And a lot of this has to do with, you know, what is going on in the last 2 years. So their attitude towards learning has really been impacted. I would say both positively and negatively. I particularly don't believe it's extremely negative because we're in a paradigm shift with learning, and we do have to adapt to the technology. So with that, I wanted to share with you what's been going on out there in terms of suggestions based on the researchers, mathematicians, and people around in the community of math. And I'd say, in fact, as well as STEM. So for those of you who don't know me, I was a good while, for about 10 years, a math coach. And then I went into doing STEM because I wanted to see if we could do applied mathematics with math and doing, right? Math and science and technology, engineering. And so what I found in the last 2 years that I've been doing STEM is I could actually insert these math routines in the morning. And I'm gonna go to the next slide to just show you what we're gonna go through. So the first thing I wanna do is just get to know what your experiences are with practice and skill work in terms of 3 questions. One is how much time is given to doing any kind of practice skill, and what is the frequency? The next one is what time of day? And the third is, what are your viewpoints about using that teaching time to check homework? Okay, just wanted to get a feel for that. And then after that, we're gonna go deep dive into all of the routine samples and film of students. That way you get to really get warmed up. So why don't we start with that? Okay, I'll leave the slide on. And if anybody, let's keep it, since the group is small, why don't we just maybe feel free to speak about any of these 3 questions. If you can do all questions, that would be great. Anybody there who wants to share their experience on this? Yes, Katina. You're on, yeah.
Yes. Hi, Rebecca.
Hi.
Hi, everyone. I'm actually I'm a STEM coach at my school. And in terms of frequency given to practice, it's very different in our youngest grade, kindergarten EC. It's a play-based curriculum, so they don't really have any sort of structured practice in numeracy. But when we get into grades 1 and 2, typically one of our morning blocks is math, and we do a lot of small group, and like we'll do a small number talk with students, and then they'll have independent practice or actually usually play with friends. So they do some sort of math. Their practice comes in the form of usually through routine of a game. So we do a lot of that instead of our students do actually a fairly infrequent number of practice problems. They rarely ever see those until they get up a little bit in 3rd and 4th grade, and they start to see more frequency of practice problems. And we don't typically give math homework in the earlier grades. We do have a lot of family, a lot of our families actually send their students to additional learning.
Yeah.
Because we have a lot of families who also are, so I work in Vietnam, and the majority of our families are Korean and Chinese and Taiwanese, and they know they're going to be sending their children back to Korea for either secondary school or university. And they tend to feel very strongly about like a sort of high like practice. So we don't actually do a lot of math homework, but we do really focus on parents and young people using math all the time. So cooking together, talking about money in their lives. Because money is mystifying because the units are crazy. So 500,000 dong is about $25 US. So kids are working with some very unusual numbers. That's what we try to do. We try to make math more like a part of our lives than like.
So that's actually very, very nice. And I would say, in fact, sometimes very different, I would say, to even how the attitude towards teaching math is here in some pockets in New York. So I'm kind of happy to hear that there is a lot of family time spent on that environment. Anybody else would like to share? Thanks, Katina. Anybody else would like to share their experience? Okay, so I wanted to go to let's get down to the actual samples, right? And I'll start with, I want you to just take a look at these 3 sample problems, and then I'm going to share with you a film. And this is something that I don't know if a lot of you have done number strings before, but this would be a great routine that you do, not more than 15 minutes with the kids. And I'm sure some of you have already seen 10 frames. These are samples. This is, I think, from Sherry Parrish's book. And you can see here that you could turn this, in fact, into a game. And perhaps one of our activities in our next session next week, if you can attend, is to turn this experience into a game at this early grade level. In grade 1, as you can see here, they're beginning to decompose numbers into landmark numbers. So 5 is a landmark that we're targeting before we get to 10. Because what you want to introduce here is the concept of half of your set of hands. And that at grade 1, I would say this is probably second semester that you would try to introduce that. And if you can, partner that with 10 frame dots. In second grade, you may choose to differentiate depending on the kind of population you have. A combination where you have maybe a menu where you get the kids to go group into 4 groups, or a breakout room maybe into 5 groups, where a group will work with 10 frame dots. Another group will work with just pure symbolic, which is like this one, 75 minus 32, for instance. And another group will create, right? And another group will decompose. And what you can do out of that is have them share. Choose 2 kids to share out of the group for that session. And that's the 20 minutes, okay? So that's basically what the routine would be. Let me show you this film. And I hope.
My job is to make college easier because students have a lot on them.
Here we go.
Hello, my name is Pat Lohr, and I'm a member of the Edmonton Regional Learning Consortium's math team. Thank you for joining me. Today I'm going to share 4 examples of number strings based on the ideas of Kathy Bosno. These examples are designed to give you some ideas about how you could use strings like these to encourage your students to develop good addition strategies. You're watching the first of 2 parts, And in part 1, I'm going to discuss the first 2 strings, which make use of a 10-frame visual. In part 2, I'll discuss the last 2 strings, and they use an open number line. This professional learning opportunity is made possible by a grant from Alberta Education to support the implementation of the revised mathematics curriculum. The file has a page of teaching notes with information in this webcast. The 4 example strings are definitely meant to be a starting point for you, and I encourage you to make use of the ideas to create some number strings of your own. I want to remind you that they are not meant to replace concrete experiences for your students, but I think they'll help you move your students on to more abstract ways to work with numbers. So let's have a look at the first example. This one uses a 10-frame visual based on Trevor Culkin's Power of 10 materials. There's certainly other versions of 10 frames, and you might also be familiar with MathRacks. What these models have in common is the anchors of 5 and 10, and I can't emphasize enough how important it is for our students to develop a strong understanding of this concept. I'm using the Power of 10 visual because I know many of you are familiar with it, and you may already be using it in your classroom. These problems are designed to push my students to use visualization and those anchors of 5 and 10 to combine numbers I'm going to show them. I use the screen shade on my smartboard, and I give them just a quick peek at the 10 frame. So here we go. You can also use the large Power of 10 cards and flash them if that's easier for you. I want to discourage my kids from counting the squares one by one, and you can see that it wouldn't be possible here. I'll give them another slightly longer look at it. And then when we're ready to discuss, I'll take the screen shade right off. Now this one is pretty easy. I always want.
So I'm going to stop here because I wanted to focus on the concept of using 5 as an anchor for 10. Early on in the year, especially K-1, what you want to do is emphasize the subitizing skills rather than the rote counting one by one. Mainly because you want to just make it a game, and that hide and seek is not about who gets to that number that is correct first, but more make it sort of that you're developing their visualization skills as well as their exercise for subitizing. It's so important to actually do this, because if you start the year with rote counting, what you're actually encouraging is too much of this exactness, and what you want to do is encourage estimation. And because it's 10 to 15 minutes for math routine in the morning, what you really want to do is also encourage just that kind of warm-up experience about math, not too much of the rigorous paper pencil experience, but more let's make this a game. And that's why in this particular case, this technology does this hide and seek approach to it. Another technology that does that is Dreambox. I have not seen other technologies do that, but Dreambox does the similar hide and seek, and I will share that with you in the next week session so that you can see other resources and whether this might be useful for you. By the way, these things are all free on site, so it's not going to be a problem for you to get this in the beginning of the year. So I'm going to go to, since we have very little time, I'm also going to introduce you to this other site, which I'm going to click. And I just want you to have access to this when you get a copy of this slide on our website at ECIS. But this is, again, another good resource for you to use for your work in school. So it's already made for you, and it actually provides some films that you can use for reference if you want some support on how to do this. Basically, all of these strings, they call these strings because they're related to each other, are only supposed to be given to kids in the first 10, 15 minutes throughout the day, whenever you're going to start your math class. So if you can do it, in fact, I would suggest doing this you know, if you're a homeroom teacher, just have them do this once they arrive, show it one by one in the board, have post-its of each of these expressions on the board, and then slowly peel it out as an onion and work it out with them. And it doesn't have to be completely connected to the math for the day. But let's say your math class is at 10 o'clock and you have the class at 8:30. You could also give this from 8:30 to 8:45. And then after that, you know, go into the other classes. Let's say you know, sending the kids out to PE. And then when they come back at 10 o'clock, you can go back and reference to that math routine that you gave and then tell a story, you know, that is based on the numbers that you're sharing from the previous math routine. So this is a great site for you to actually refer to, okay? What I'd like to do now is, if perhaps since we're very little, we're a few people here, I have a menu here of several breakout rooms. I have 4 breakout rooms. We're not going to go into breakout rooms since we're a very small group. I wanted to see if we could work together. Let's use breakout room number 1 as a sample. I wanted to create 2 relational expressions after these 3 equalities. Yes, Katina.
I had my hand up still. Never mind.
Oh, sorry. Was it up a while ago?
Yeah, but I took it down. Don't worry.
Oh, okay. So does anybody, I mean, I would like to examine this, okay? And I don't think kids are used to seeing this kind of, I would call this a number sentence, right? A 9 plus 4 equals 10 plus 3. What they normally see is what is 9 plus 4 equal and then blank. Now, the reason why there is a move towards showing this is you want to introduce children towards early algebra. So for instance, in kindergarten, what you would do is dot cards on one side and then an equal sign in between, and then another dot card on the other side. In this particular case, the 9 plus 4 equals 10 plus 3 begs for an investigation on whether kids understand 10 plus 3 in another form where you are removing 1 and adding 1 to the other side. Has anybody had an experience of sharing a problem like this to children, let's say in the grade 2 level? Yes, Katina. Yep.
Yep. For sure. I think that what you said was really true, that we tend to use sort of a, usually like we're missing some value, but we've really started to move towards these ideas like this is actually, and this is an equality and these things are equal. Let's investigate it with concrete items if we need to, or let's draw and represent this. And it really helps later in second grade when you start doing compensation strategies. So they start to see that it's, you know, if you're doing a subtraction, it's really the space between the 2 numbers on the number line. And so you can move those around to fit your will. And it's really great when they've had this basic part so that they understand the more challenging aspects of compensation.
Yeah. So I'm glad that you mentioned the number line, because the next question I was going to ask was, what models are we using to partner with these expressions? So yes, you can definitely use number lines. At kindergarten, you'll probably use again the 10 frames, dot cards, or even rocks if you're, you know, using natural materials. You know, you put 9 rocks on one side, you know, 4 rocks on the other, and have them start to look at these in clusters rather than one by one. this kind of activity can be done even when the numbers are below 5. And it's fascinating to actually watch in a regio classroom. I've tested it in a regio classroom, and I'm absolutely an advocate for using equalities like this, even at the regio level. But again, definitely not using these sizes of numbers, right? If you're first term teacher, I would even just stick to the 5s. 3 plus 2 is equal to, let's say, 2 plus 3, something as similar, simple as that. So why they're strung together, okay? So if you look at 9 plus 4 is equal to 10 plus 3, if I go to the next row, which is 9 plus 5 is equal to 10 plus 4, what you want to examine here is whether the kids are noticing the change, right? And you could use, again, I want to go back to the models that you're using. If you can use rocks, if you can use leaves, have the kids pick up small leaves in the forest, if you're lucky enough to have that access. Have them do that as a way to start to examine mathematics from a very ground level of numeracy. And what they say in providing string work is you can jump towards the middle of the string into a larger number and see if the kids can still see the relationship between what you're trying to do from the previous two. Clearly, this one is grade 2 at this point, right? So again, I did this whole set of strings because we're looking at K-2. And I wanted to ask, perhaps, some of you, if you come and join back, to create 2 relational expressions for each of these breakout rooms samples, so that you can test it, see if it works out for you. As a matter of fact, if you don't return for next week, it would be great if you can actually test some of these out in the classroom, modify it a little bit, but maintain the tension of the slight change. What's key here is the first 2 rows of the expressions of the equality have to be very closely related to each other. So in this particular case, the 4 and the 5 is very much related, and the 3 and the 4 is very much related. That's extremely important when you're doing a routine like this, is having something that is grounded on being the same number, but have a little bit of a change on the second number. Okay, you can also flip that too. So you can see here very carefully, the number is changing, not too big, but still related. Same thing here at breakout room 3. You can see this is 19 is the same, 26 is the same, but you can see here the other side, you're beginning to exert a little bit more rigor in terms of whether they can find the difference of the change, okay? Now, in the 4th one, which is also a nice string to have, let me just move this because it's bothering me. This is another method where you can have the kids settle in one corner of the room and have them create 3 expressions that are related to this particular marker expression of equality in the beginning. Now, so the way I've set it up here is you've got an easy, right? And then breakout room 2 and 3 would be sort of in the middle. And then breakout room 4 is more of a challenge, right? And what you could do is cut this, enlarge it on the photocopy machine, and then cluster your groups differentiated. And you could even do this when the kids are back, you could have them do it in different parts of the room. That way you don't have the viral load problem that we have with COVID. Another way to approach it, if you're doing hybrid, is to partner a kid that's on school, on site with another child that is at home and have them go into breakout room. So there are many ways to actually do this routine, right? And then you let them come back to you in 10 minutes. You will rotate from each room to the next or each group to the next and see what happens, right? So it's very important that they get an experience for that. Now I changed, you can see here, I also changed the graphics of this, okay? This is another way of starting a routine where the whole class works together. So if you have a hybrid situation, for instance, and half the kids are on site, half the kids are off site, what you could do is have kids work in teams. And if they are on site, they could use Post-its, right? They could put the numbers inside these circles to play around. So it's kind of like a game. So place the numbers 1 to 9 on the circles of the larger triangle so that the sum of the numbers on the larger triangle is double the sum of the numbers in the smaller triangle. And the nice thing about this is there's more than one answer, right? So the kids are not going to be anxious because there's millions of ways to do this. So this, again, I highly recommend you try this. It works hybrid, it works clearly on site, and it also works if you're purely virtual. So I want to focus now on the research and why this is so important, okay? In the past, right, definitions of mathematical proficiency were focused on the white colored fonts, okay? So, Katina, I just noticed your hand's raised. Can I help you?
Nope,
Oh.
I'm just forgetting to unraise my.
Okay. So for everybody, just raise your hand, okay? Because I just wanted to I'm trying to focus on covering this aspect of the research on brain research. They say that in the past, there was a lot more focus on detail, under attention, and pace, right? So we would time the students. Now, they're saying that given the paradigm shift in education, paradigm shift in technology, paradigm shift in a lot of societal areas, especially as a result of the pandemic, very, very important that the attention aspect of our neurodevelopmental system should focus on estimation and adaptive disposition. Now, adaptive disposition is really important because what you want them to do is to adapt to the change that you are introducing, right? So for instance, I'll show the example of that, right? Because there is more than one answer, what you want to encourage with children is the ability to adapt to not only if it doesn't work with their original, their original attempt, but you want them to collaborate with others to look at other ways. So the adaptation is really, really important, right? They shouldn't be focusing too much on how fast they can do it, nor sticking to one particular area in that triangle because they like that particular, unnecessary stuff like that we normally can get caught on with attention. So I emphasize the two words, estimation and adaptive disposition, in red because those are critical for today's definition of mathematical proficiency. The next one is spatial ordering, okay? So before, the focus on the traditional mathematics was on geometric perception, like where are the edges, where's the corner, okay? We're looking for kids that can find that. We're also looking for kids that can represent certain shapes. Let's say, if we say, draw a square, draw a rectangle, okay? So in today's demand for conceptual understanding, what you want to do is actually encourage visualization. In other words, ability to create that visual into different forms. And scaling, which is proportional reasoning, which is you want to introduce to them the sense that something far and something near can actually be the same shape, but because you're farther, it's going to get smaller. Okay, so proportional reasoning is very critical in spatial ordering. Now, for memory, this is very interesting. They say that we were so much more focused in traditional education with procedural recall, factual recall, active working memory. You know, if I ask you 2 times 3, give me the answer quickly, you know, that no longer applies. However, unfortunately, parents still think that, or, you know, a lot of parents actually still think that that's important. The research shows that pattern recognition, creation is very, very important. So it's not just you're given a pattern and you have to recognize it, but you have to create a pattern. The next one is declarative memory, which is semantics and episodic. Semantic is finding meaning in what I am recalling, okay? And then episodic is when did I, yep, did somebody, oh, okay. And episodic is finding, you know, a story that's behind that memory, right? Can I relate to that past to my current learning? Okay, so no longer is disconnected memory important, like procedural recall, right, or factual recall. We used to say the times table. Can you give me 2 times 3, and then I want you to give me, you know, 3 times 12, something that's unrelated. That is not what is required. What is required is being able to relate one learning to the next learning. Okay, so that's why, again, those 3 are emphasized. Moving on, in terms of language, we used to put an emphasis on memorizing word meanings, symbolic meanings, right? DOG is that image, for instance, right? Image of a dog. Now what they're saying, and I think this one is really important, is the tenets of reading comprehension in literacy, we need to bring into mathematics, because mathematics is not separate from literacy. It is together. We should somehow partner with our reading teachers for reading comprehension, because you use the same strategies basically. The other piece that's very, very important, and I think nobody will argue, is hidden meaning, because this helps a lot with inferring, especially in word problems and statistics, right? And probability. The last one is really important, the next bubble, higher order thinking. So before, right, what we would define as higher order thinking was rule understanding and concept formation. So you know, this is very common. If we have a pattern of 2, 3, 4, 5, everybody, you show that to them, and then the teacher will ask, so what is happening in this pattern? And then everybody say, oh, you're just increasing by 1. Well, nowadays, that's really not the focus, okay? That is probably, like, in terms of Bloom's taxonomy, that's like way, way, way low, right? What is important is to be able to relate certain patterns to the other patterns. So what you don't want to have is just one pattern showing. You want to increase that understanding by using comparative skills to relate to the previous pattern. Strategic disposition is very important. especially if you can develop that very, very early in the early years, because that helps the child create, innovate. Okay. So all these red highlighted words are so important. I didn't want to remove the white font words because, okay, it is still important. Okay. We do still need to do rule understanding, but that should not be the emphasis. And it's still important to recall facts and use your active working memory, but that is no longer the focus. Okay. Those three aspects, sort of the red colored words are what is really front and center now, and it's in high demand. If people are looking for jobs, you know, in their future, these are critical. Then I wanted to show you a vertical articulation of traditional mathematics and how that compares to that chart that I showed you. As you can see, that previous chart was a very kind of messed up, you know, divergent way of looking at learning. In traditional mathematics, we see it like this. It's very linear, right? So we align it with age, and then the learning trajectories are there. And then we sort of cluster it by grade. And then what are the topics? And that's how basically a textbook is designed. We go chapter 1, chapter 2, chapter 3. And we say, oh, you can't do unitizing unless you do rote counting, right? You can't do ordinal number counting until you do subitizing. That's not true. Now what happens is you actually cluster these. And these particular trajectories could be applicable to any of these. Could be applicable to spatial ordering. You could be unitizing here in spatial ordering. Could be unitizing in memory because you're looking at pattern. And you could also be unitizing here in higher order thinking because you're looking at relational thinking. So when you're unitizing, which is to name how many objects are there in a set, you really want to be able to teach them the skill of unitizing early rather than delay it at 6 years old. You know, introduce it at a very small level, you know, achievable level. At 3 years old, show them a bunch of rocks, like 3 rocks. You know, show me that in terms of leaves, you know, have them start to compare it. 3 leaves, you can say 3 sticks. You can even have them look for sticks that are the same size, for instance, right? So those are all developing skills of subitizing. But what they do say is do not, I don't want to sound too sort of too strict, but if you're in a school that teaches traditionally, make an effort maybe to pilot a little bit of introducing your lessons this way, right? Like for instance, today you could focus on estimation or visualization together. So I wanted to actually share a podcast that kind of hooked me in. This was in NPR last year because one of the things they did say is that learning can be so much more fun when we put mathematics in light of our worldwide experiences and multiculturalism. And I think diversity in collaboration makes for a richer math routine. So let's listen a bit to this podcast. It's not going to be, I'm not going to play the whole thing. I'll have you guys have access to this when you're able to, but let's listen to a little bit of it, okay?
Support for NPR and the following message come from the House of Roll, whose Rio Bell kitchen and bath fixtures combine European and North American traditions. Hit the play button below to learn why Vice President Luc Lefebvre believes the kitchen and bath industry shares DNA with the fashion industry.
This is Hidden Brain. I'm Shankar Vedantam. In 2011, Richard Freeman was working on a project. He was studying the way groups of people work together, specifically how scientists work together. Richard, who's a Harvard economics professor, noticed something intriguing. Scientists in the United States seem to stick to their own kind.
You'd see Chinese folk concentrated in one lab, Indian folk concentrated in another lab, Europeans of different groups associating more with their compatriots.
This was not surprising. You see this kind of clustering in lots of workplaces. But Richard thought science ought to be different.
In general, people who are more alike are likely to think more alike. And one of the things that gives a kick to science and scientific productivity is that you get people with somewhat different views, different perspectives coming together.
This assertion has long been debated. Some people say teams with lots of different perspectives come up with better ideas. Others say, no, when a group has lots of different views, this can produce conflict, gridlock. So, which is it?
So on your own, perhaps if you have time, I would highly recommend listening to that. It's 30 minutes. It's not a big deal. Excellent viewpoint about, the idea of diversity in collaboration. And I'm talking about this because I don't know if much of mathematics, because of its nature to be very, very symbolic and I would say even cold, that a lot of kids get turned off by it. But if we bring in culture into the mathematics and create multicultural perspectives for lessons and integrate them into history or games of other countries, for instance, we're able to share with the children the differences in learning mathematics. One example that has been digitized recently is this site where kids can actually play together, drawing a mandala. And what I would highly recommend for you to try is perhaps once they start during the year, and like what Katina was saying, have them create small mandalas with chalk, with natural materials, with pattern blocks, so that they can start to warm up towards thinking about math routines as very engaging experiences, very positive experiences. So I wanted to end our session today with basically letting you know that a math routine doesn't have to be all numbers. It can be as visual as a mandala. And it also has so much potential for bringing in the various aspects of your children's cultural experiences, wherever they visited, for instance, where they come from, okay? Have them particularly integrate that into your math experience. So like I said, in our next session, what I'd like to do is, so I don't want to extend, it's already 9:15 and I wanted to keep this simple. For our next session, my goal is to actually work on some actual student work. You can actually, we'll be looking at some films of students actually doing math routines. If we're a good enough group, I'd like to be able to experience creating as a team. So, I'll be sharing these slides with the next group. And since this is going to be recorded, and if you, let's say, stepped out for a moment, feel free to actually view the recording, and then after that, be ready to jump in for the next session. Any questions from the participants?
Thank you so much, Rebecca. I've just popped in the chat box the registration link for next week's session. If anyone hasn't signed up yet and would like to join, I will make sure that everyone receives this recording along with the slides. I'll do a follow-up email towards the end of the week to make sure you've all got that.
Great. Thank you, everybody, and hope you have a good summer break.
Thank you very much, Rebecca.
Thank you.
Thank you.
Bye.
Bye, everyone. Thank you.